Good afternoon, everybody. Welcome to another exciting afternoon of organic chemistry, Chem 170, with your host, me, Dr. White. Hi. All right. First of all, one of your colleagues just asked, and let me just do one thing here, and about my YouTube videos. So let's take a look at them. All right, do you see on the screen my YouTube videos? By the way, how'd you like my Halloween YouTube with my cyclohex lavalier? All right, now if you click on that and open it, and let me move this, get rid of this. Good, yeah. Yeah. But anyways, do you see it on here? You see where it says more? Click on that. Do you see what I have there? Topics. Now, every one of the videos has that. So you can go back and see, well, what is in that? And these are all the things I talked about. That's Happy Halloween from Dr. White's robot. Am I crazy or what? Don't answer that. But anyways, these all have them. And if we go back, oh, let's pick one at random, whatever. What was I doing on 1010? And if you haven't figured out the file name of the video, year, month, day, and then the class. And I also put the week there so you can look at the syllabus too. Do you see there what I have on? Good afternoon, everybody. Wow, that sounds familiar. Do you see where I have that, Ignacio? Is that what you were asking about?
Yeah, I didn't see it there.
Well, now you do. Aren't you glad in my world there's no such thing as a dumb question? It's a
I'm
good
used to seeing
question.
it.
And
I'm
now
used
you
to seeing it in
know.
the title. Yeah.
What?
I'm used to seeing it on the title, like where you have
Well, guess
the
what?
date.
There's not enough room.
Yeah.
Because how am I going to put in the title
Right.
all of this?
Yeah.
Nope, it isn't going to fit.
Yeah.
And now you know. So you now have information to figure out what's in each video. Who's that guy? I don't know. But anyways, does that answer your question? All right. All right. Before we get it back to organic chemistry in terms of new stuff to learn, but before that, I have to, it's cold outside. Did I tell you I'm a tea drinker? This is blueberry tea from the Republic of Tea. My other favorite one is vanilla almond. And a third favorite is their hot apple cider. It's on sale now. And oh, that's dangerous. All their teas are good. Well, not all. I had one tea that was so disgusting. I called them and said, did I get a bad batch? And the person at customer service said, no, a lot of people hate that. And I'd only bought one container, not a big bag. And she said, you don't like it? No. And I've been a long time customer. She said, just throw it out and we'll refund your money. And they did. It's a great company. All right. What I want to talk about is next Wednesday will be test number 3. Test number 3 will cover carboxylic acids, carboxylate anions, esters, in other words, carboxylic acids, their derivatives, and amines, amine salts, quaternary ammonium salts, my favorite. And also it will cover amides, nitrogen derivatives, and also a little on heterocyclics. Before Friday, so let's make it before Saturday morning, I will post and send out in an email the information about test number 3. I just told you I'll cover what chapters. And it's usually historically, I got to write it in the next 2 days first, but every semester I rewrite my test. But I know it will be 9 pages. The breakdown will be about similar breakdown to the point breakdown for test 2, other than it'll be for carboxylic acids, carboxylate anions, esters, and also amines, amine derivatives like amine salts, quaternary ammonium salts, and also amides and heterocyclic compounds. And it will be given next Wednesday, just like I've done all the rest of the semester. I'll send out an email so you can open up with a password a PDF file for test number 3, and you'll have until next day, whatever, 11 or 12 or 1 p.m. to upload it as a single PDF file. And by Sunday or earlier, I'll have the results out both in D2L, and also I will send out individual emails with your score for each answer. All right. Let's see. No, we don't have class on Tuesday. So, next Tuesday is election. And now let me get serious. Brave men and women have died so we can vote. I've never missed a major election. Once I was in Germany and I forgot to get an absentee ballot. I missed a local minor election, but I've already voted already. Please vote in Illinois, and I believe in all the counties in Illinois, at least around Chicagoland. I assume the rest of the state. I think they have same-day registration. And right now in Cook County, I live in Cook County, but I'm sure in DuPage and Kane County for most of you, that there's early voting going on. Vote. I'm not going to tell you who to vote for. I know I vote for. The people aren't going to destroy this country, but that's another story. And you can always talk to me in private about that, but vote. All right. You know something? I feel like I and you could use a pick-me-up. So what can we do for a pick-me-up? We can play that fun game. What fun game? And that fun game is circle and name the functional group, 2 points each. And that's the game where I'm going to write down some molecules and you're going to circle, not the name the whole molecule, circle and name the functional group. Ooh, I saw somebody sent me a chat. I forgot. Someone asked, are the esters lab to be due next Wednesday as well? And the answer is yes. We're not having class. Well, we don't have class on Tuesday, but there's still going to be class on Wednesday. And later today, I will go through, after I'm through with my lecture, we'll only go about 45 minutes or so with the lecture like I normally should have done if we were face to face, but I've cheated this semester to get in some extra practice. I haven't finished D yet, so I better shut up and do it. Then I'll talk. There you go. And let me just fix up something that looks ugly. Don't look, don't look. You looked. That looks better. All right, your turn. Circle and name the functional groups, 2 points each. Huh. Question, is there extra credit on the ester lab? It has a lot of questions. And the answer is no. I've been pretty nice this semester. Don't tell anybody. I haven't done a lot of questions, but if you look at the ester lab, which we'll do later today, there are not that many questions. At the other school, general chemistry lab, that is in a lab book, sort of. They're doing it online, and it's just a company that makes the labs. I didn't. It has 15 questions for the students to answer. I cut out a few of them, but it's still at least 10 of them. So, does that answer your question? Remember, if you have any questions about anything, including the lab, you can always come to my office hour. Don't forget, tonight from 6 to 7:15, I'll have my office hour. And when you're done having fun, playing that fun game, circle and name the functional group or groups, 2 points each. Give me a thumbs up and I'll do it. Is it still warm where some people are, where they don't have to wear top long sleeve? Nah.
It's 91 yesterday and
No, I
humid.
wouldn't like that. I don't like hot weather. I'm not a summer person. Now is a nice time of the year, beginning of winter. Winter itself, as long as I'm indoors, is nice too. I can look out the window and see it snow, and I don't have to shovel it or snow blow it. All right, everybody done. Going once. Going twice. All right, my turn. How do you play that fun game? Circle and name the functional group, 2 points each. You look for what's different. What's not carbon, what's not hydrogen, should get your attention like this. Hope we got your attention. And if we look at the first one, ooh, and let me do this in red. Oxygen there, and this you don't have to do, but I will. We have a carbonyl with a hydroxyl group and carbons here. What is this? A carboxylic acid. If we move on to B, what do we, ooh, another oxygen, carbonyl, carbon double bond to oxygen. Remember I told you in ketones and aldehydes how important the carbonyl group is to Dr. White, Mother Nature? It is. Oxygen here, and this oxygen I have carbons. I'll call that R prime. And on the carbonyl carbon, I have a ring, which is really this. And so what do we have here? An ester. And then we go to C. Ooh, a nitrogen with hydrogens and a carbon. And what is this? It's an amine. And here I show you a general mean. R prime and R double prime can be hydrogen. In this case, they are. Oh, we're not done. There's an oxygen here and here. And we have a carbonyl, carbon double bond, oxygen with a negative charge and a cation, M plus, where M can be, for my class, sodium, potassium, or lithium. And I've got carbons here. I'll call that R. What's this? It's a carboxylate anion. And let's move on to D. And D, ooh, look for what's different. Oxygen, nitrogen, carbonyl, nitrogen. There's stuff on the nitrogen atom, and there's stuff on the carbonyl. And here again, R prime and R double prime can be hydrogen. In this case, one of them is, and one of them's carbons. And what do we call this? An amide. Am I done? Oh no, there's an oxygen here and here. Carbonyl, oxygen. This oxygen has carbons. I'll call R prime. This carbonyl carbon has carbons. I'll call that R. What do we have here? An ester. And that would be an ester. Am I done? Oh, no, one more. I threw everything in here but the kitchen sink. And my kitchen sink is clean, so I could have thrown it in. But anyways, a nitrogen. And it's got a plus charge. Notice it has carbons here, plus 3 more. It has 4 carbon groups. Plus charge. And, ooh, chlorine anion, halogen anion. Remember, X can be chlorine, bromine, or iodine. And what is this? It's a, and I'm going to come down here because I need more room to write. It's a quaternary ammonium salt, something near and dear to my heart because I worked in it for a number of years, companies that made quaternary ammonium salts, and I have a number of US patents. And that's how you play that fun game, circle and name the functional group or groups, 2 points each. Now, let me remind you, if you can't do this successfully, how can you name a compound? You can't. If you can't do this, how are you going to know how it's going to react? You can't. So this is an important but very fun exercise you should know how to do. Any questions? I have a question or two. Anybody happen to pick up a bottle of vinegar and look at it and say, aha, you don't have to do the aha stuff, but you say, I know there's acetic acid in that bottle. That's what makes up vinegar with water. That is a carboxylic acid. Did you happen to pick up a bottle of ketchup or mustard or a jar of pickles and look at the label and see it has vinegar in it? And that, as you know, is acetic acid and water. The acetic acid is a carboxylic acid. Did you happen to pick up a bottle of nail polish remover? Notice I forgot to polish my nails. Dr. White will never be a nail model on TV. You know, I see their hands, not me. But anyways, and look at the bottle and it says ethyl acetate, and ethyl acetate is an ester. Have you done that? Oh, let's do one more. Did you happen to pick up a box of or a bottle of fabric softener and know the active functional group in fabric softener, because your clothes nice and soft and anti-static in the winter, is a quaternary ammonium salt, near and dear to my heart. Did you do that? Remember, organic chemistry is all around us, and it won't hurt for you to think about it when you're not in my class right now. Trust me, I'm a doctor. Did that work? How about trust me, I'm an organic chemist. Did that work? Trust me. All right. If you remember on Monday, we were talking about polymers. Polymers are macromolecules, big molecules that have repeating units. And I taught you on Monday how addition polymers are polymers that have only one type of monomer. Monomer is the building block that makes up those polymers. Think of a polymer like a long freight train that has boxcars. And addition polymers has only one type of boxcar, same over and over again. Now, condensation polymers have two or more different types of monomers. And think of that, you may have a red and then a green, red, green, red, green boxcar or boxcar tank wagon. Not tank wagon, tank car. Now, when it comes another way of differentiate polymers, and I gave you examples of addition polymer, saran wrap, condensation polymer, the plastic polyester by water bottle. Those are things you should know. Again, I should mention what I'm doing now will be on test 4, not test 3. And let's go on. Next, I talked about last Monday, and you can go look at the video and enjoy my cyclohex lavalier I had on, the colorful cyclohexane product. And there are two types of monomers based on another type of way of classifying polymers are by a key physical property. And the first one is a thermoplastic, which means once formed, you can reheat that shape to form a new shape. And a polyester by pop bottle or water bottle and saran wrap would be examples. Now, thermoset, once you make it, it can't be reheated and reshaped. An example of that would be a rubber tire. That's your car tire or bicycle tire. All right, next couple of slides, click. The switch will be in the off position, but still, this is something interesting for you to learn about. Now, addition polymers are mainly what's called free radical polymerization. Now, I'll be honest with you, I could do a whole 2-semester graduate level course on radical chemistry and polymerization. So I'm doing in 5 minutes what I could do in 34 weeks at a grad school level. Yes, I have worked at 2 companies dealing with polymers where I've made polymers or developed new polymers. At that point in life, I had chemists and PhD chemists. When I asked them to do this or work on a project, they did. All right, so addition polymer, same type of monomer. And what does it mean? Now, addition polymers, the monomers are usually what's called a vinyl group. Vinyl group is a double bond attached to something else. And polymerization chemists or polymer chemists use the letter L. Why? Don't know, because I've been different types of chemists. And we have what's called a radical initiator, a catalyst. And there are different ones. Certain ones are peroxides. And what happens is the radical initiator forms a radical. And a radical is where you have an electron on a carbon. We show like that. It's not really a charge. And when you have a double bond and this attacks that, to form a new radical and switches off. And this new radical can react with more of this to now give this. And this can react with more of this to keep on putting on. And the group you're putting on is the monomer, but where you lose the double bond. And that's why I show it this way. And in polymers like this, N is on the order of about 1 million or 1.5 million. That's big. That's why they're called macromolecules. Now, switch is totally off. Everybody see a key monomers table on your chip? Let's see if I can make it a little larger. Is that easier to read now? All right, when L is a hydrogen, the monomer is called the common name ethylene, and it's called polyethylene. And the polymer, again, switches off, saran wrap. When you put a methyl group as L, you get, this is called propylene. That's the common name for this molecule. You get polypropylene. And it's similar to saran wrap, but it's harder. Have you ever bought something like a flash drive or something that's on a card with that bubble plastic over it, shell? It's impossible to open up. You know, it's really hard. That's polypropylene. Now, when L is a benzene ring, this has the common name styrene. And the polymers, polystyrene, when you make it as a foam, have you ever seen those insulated white cups you can get with the hot liquid so you don't burn your hand, just your mouth? But anyways, or the coolers, the super cheap light ones of those white beads, that's polystyrene. And different L groups, you can see different monomers. Now, the very second to last one, when L is a chlorine, this molecule is called vinyl chloride. It would be chloroethene, would be the IUPAC name. Now, when it reacts together, it forms a polymer called polyvinyl chloride, which is shortened down to PVC. If you look underneath your sink in your kitchen or bathroom, do you see the white plastic pipes? That's PVC. It's made by an addition polymer of using this monomer. And when all the hydrogens are fluorine, you make a polymer that's called Teflon. And that's used for your non-stick pots and pans. And it's also a very good lubricant. All right, switches on, click. Turns out when they started making polymers or natural polymers, rubber from a rubber tree is a polymer, but it's this goopy mess. Let's see something. Who's that good-looking guy on there? Don't answer that. All right, do you see the tree on there? See the white stuff coming out that looks goopy? Wow, that's scientific. Thank you, Christiana, and also Ignacio. That's real raw rubber. It's a goopy mess. You can see it right here. Let's see if I can. You see how it's sort of in the bucket here? And here's some that's, and this is good, not that good for stuff. Well, you can sort of put it on certain materials. Well, it turns out in the early 1800s, a lot of people were trying, how can we make rubber into something useful. And there was this one inventor who got the first patent and was able to commercialize making that goopy stuff into something useful. And his name was Goodyear. Anybody ever hear of Goodyear before? Like in Goodyear tires? Well, what did Goodyear do? Now, if you look at rubber molecules, polymers, think of it as long molecules like this, like pieces of string. If you had a couple pieces of string and you pull it this way, it's pretty strong. But if you had 3 or 4 pieces of string this way and you pull it this way, it would fall right apart. And that was the problem with the type of rubber you just saw from the rubber tree. And what Goodyear, others were experimenting, but he was the first one to commercialize it. If you can link these together by forming chemical bonds with something, it makes it much stronger. Because not only this way is it strong, but now you can't pull the strings apart. And this is called linking, cross-linking. And you should know that. Cross-linking is when you form chemical bonds between the long polymer chains, right here, right here. And you can affect different degrees of cross-linking to get different physical properties. And the important thing is it makes the polymer more rigid and stronger in certain physical properties. Now, sad story about Goodyear. I think his first name was Charles. And here's a sad story. He was an alcoholic. And in the 1800s, these two very astute businessmen saw his invention and his patent and went to him and said, we'll give you a lot of money if you sell us the rights to your patent for all and your idea forever, and let us use your name. Because at that time, people knew about him. He was famous. And being the alcoholic who wanted money, he did. And he got the princely sum of I don't know how many thousands of dollars. Remember, in 1808 or 1810, whenever he did that, we're talking lots of money, millions, because maybe the average person made $10 a year or 15. Prices were a lot lower. Well, being an alcoholic, unfortunately, he drank it all away and lost it all, however. And what you don't know is there's never been a Goodyear involved in Goodyear tires. The two businessmen who did that. Sad but true story. All right. I just did a quick review of what I've talked about. Remember, a condensation polymer is made with 2 or more different monomers, and each monomer has to do this has 2 functional groups, such as a diol to make a diester. Now, usually, but not always, the functional groups involved in a polymer made by condensation polymerization is either an ester or an amide. Now, there's another one that you can make with urethane and another one, phenol, reacting with formaldehyde in the aldol type condensation. And then I won't get into, but I could, epoxy groups, ethylene oxide type or epoxy that react with alcohols or amines. Now, switch is totally off for now. If we have, as you can see on the slide, a diacid, carboxylic acid, di means 2, notice 1, 2, and a diol, OL ending alcohol, di2, dialcohol. Notice I made this ester. This is another way of writing a carboxylic acid. And for test number 3, you should know, I don't have acid catalysts here. You make an ester. And here's my alcohol, here's my carboxylic acid, here's my ester. But now at this end and at this end, I have more acid, carboxylic acid, and more alcohol. And you can react that with more diacid or diazoles to make a macromolecule, polyester. And that's how they make the material for this bottle. And depending on what R and R prime are, you can have different types of polyesters. Now, polyamide, remember an amide, which you should know for is made by taking a diacid or polycarboxylic acid, poly means many, and react it with a polyamine, that means more than one. Now, here, instead of using a carboxylic acid, we're using a acid chloride. And these react very quickly with amines, just better than carboxylic acids, but making amide. But you generate HCl, which is why you have a base present. And here, if you take this diamine, notice 1, 2 amines, and this diacid chloride, you'll make this polymer. That's the repeating unit, like a boxcar and a train. And then here is the order of 1,000,000 or so. And when you weave that into a fabric and put layers of that fabric together, we make bulletproof vests for military and police. And that molecule, that polymer, is called Kevlar. How many of you have heard of Kevlar bulletproof vest? And the benzene rings help give it strength, and it's also cross-linked. Now, urethane, polyurethane polymers are used for insulation, and also, again, remember, switch is off right now. For insulation, and also there's 2 types of polyurethanes. One's solid, one's liquid. Not liquid, flexible. Hold on, I gotta get something. Show and tell coming. All right, I'm back. Now, this is called the isocyanate functional group, which we really didn't talk about it. It's got a carbonyl double bond to nitrogen with an R group on it. And it's very reactive and like a carboxylic acid, but much more reactive, really reactive. And if you react that with a polyol molecule with a lot of hydroxy groups here, I just have one, and you use a tertiary amine as a catalyst, and I'm missing a hydrogen here. Ooh, can I write it in? You make, this is a urethane functional group, and it's very stable. Now, I have a number of patents in urethane molecules used in urethane production, foam production. And how would I call this? A badge of honor is if you can make something that's fun to make to show how good you are with making urethane foams. And that's the hanging cup, or I don't know what else you call it. Everybody see this? See in there the urethane? This is a solid urethane foam. It took me 4 tries to get the right amount of catalyst that when I poured it, it solidified just like this. Does that look cool? You can say no, it's permitted, but I think it is. It's a badge of honor that you can do this. And when I was making my phones for one of my patents, we'd make it in here and I'd make it enough to fill a whole box that was like 2 feet cube. And we cut that up to run various tests on there. ASTM, American Standard Testing. I forgot what the M stands for. But this was used with one of the chemicals. Oh, it needs to be dusted out. Sorry about that. Don't look, don't look. Anyways, that's how you make a urethane. And this type is used for, not this one, because it's a high density foam, I use as insulation. See, I wasn't lying. I know this stuff. Ooh, wait, let's do something. No, I don't have time. The last one, which I also have patents in, is phenol formaldehyde. And what you do is you take the phenoxide anion and switches off, plus formaldehyde. And this reacts like this to give you this first step. You have two of them. And then the other ortho-para positions can react with more formaldehyde. You do this in the presence of base to make this, and it can get super huge. And let me go. You see this over here on this right? And it can keep on going a lot bigger. This is called a pre-polymer, molecular weight about 700. But when you polymerize it finally, it gets super huge, millions of carbons. And this is used as a glue. That's what her fancy name is, resin. One of the biggest areas is to hold wood together to make plywood or particle board. The other thing where I worked then, it holds sand together to make the molds to make things in foundries, like your car engine. So I have time, I do. One of my patents, I invented a new environmentally more friendly and better acting resin for foundries to make car engines, among other things. And one of my fondest memories is a number of years ago, after it had been sold for a year or so and it was quite popular, one of our biggest customers at that time, when I worked for that company, I don't anymore, that was called Board and Chemical, now called Hexion, was GM, Chrysler, now Daimler Chrysler, and Ford. And I got a call from our salesman, who and also VP of marketing and sales, that the superintendent of the what's the city? Was it Windsor, right across from Detroit? I think it is. Hold on, let's get a. think it's Windsor, whatever, let's assume it's Windsor. The Ford, yeah, it was a Ford Windsor plant because we went to Detroit and we went over into Canada. You can do that from, was it Detroit? I think it was, maybe not Detroit, but somewhere in Michigan. Anyways, I was invited because they were now using my resin to make Ford engines, and the neighbors and the workers were happy because it didn't stink and burn their eyes because of my resin was environmentally friendly. And I got to, they gave me a tour of that, and it was quite nice. One of the things I saw, when you make things, you do what's called quality control. Chemical industry, we have, it's called QC lab. And they took me to their QC lab, and they had a full-size Ford V8 engine, and they were cutting slabs of it this way to check the metal, that there were no bubbles in there or anything like that. And I said, wow, I wish I could take one of those home as a souvenir. And the QC manager and the plant manager laughed and said, go ahead, try and pick that up. And it was a couple 100 pounds each slab, because you know how heavy a car engine is. I said, I don't think I'll be able to carry that on the plane back to Chicago. We all laughed, but that's a use for that type of polymer. Oh no, I timed it just about right. Like I said, I could also do a whole 2-semester graduate level course on just polymers, and in about 45 minutes or an hour and a half, I've done it here, gave you a good taste of it, under some important areas to understand. And with that, we're done with the polymers on Monday. And let's take a 5-minute break, and you'll have to wait what's going on Monday. Come back, 5 minutes break, and I'll see you at 1:55. I'm gonna get up and stretch. I'm back. Oh, I forgot to tell you. Remember my cyclohex lavalier? Well, I wore that on Halloween after our class when all the kids were coming to my door. Boy, there were a lot out this Halloween, which was very nice. And in my neighborhood now, there are people of my age, a lot of them moved out, maybe went to Florida. But anyways, there are a lot of families now with young kids, and they're all coming around and they loved that when I was going like this, and their parents loved it too. And now because they're older, like 6 or 7, my neighbors have their kids going around, and my neighbors across the street from me are very nice, and my neighbors on both sides, they set up where in his garage they had a Halloween party with food and everything. And they came over and said, don't forget to come over. And I did, and it was a fun time. I also got to take some of my flashlights out and press them like that, or this one. This one, the light here will go about 3 football fields. It's really very high end class, really classy flashlights. Yes, I'm addicted to them. But anyways, if we were face to face now today, we would have had our 50-minute lecture in a lecture room and then do the lab. Now, I've been cheating this semester because we're on face to face. We're not. I can do a little extra so I can do more examples, which I have been, because we're not face to face. And I think that helps you on with the online course. But because we're on track and everything's good, guess what time it is? It's lab time. I got to open up the lab first, I just realized. All right, everybody see carboxylate anions ester lab? And that's today's lab. Today's lab deals with esters, and they're an important part of nature. They're responsible for the odors and taste too of many fruits. I don't know, I've never eaten a flower. Have you ever eaten a rose? Or I guess they make dandelion stuff, but anyways, and for the smell of polymers. And they're also used to make polymers. Now, carboxylate anions are useful in many, and I'll talk more about that later. Now, they can be soluble or not soluble in water. And this is due to hydrogen bonding. I'm talking about the carboxylate anions. Now, in first made part of this lab, what you're going to be doing is making an ester. Oh, wait a second. Warning, warning. I'm going to do some artwork. Don't break a rib laughing too hard. That's not what I wanted. That's what I wanted. All right. One of the reactions you're going to be investigating today is the following. And here you take a carboxylic acid, react it with an alcohol, with an acid catalyst. And for this lab, if we were face to face, you'd find out about sulfuric acid, which is a dangerous acid. But if you know about it, it can be handled safely. Students have done it for years to make an ester. And what you do, you'll be changing the R group and R prime and making different esters. And the way we do it is, and I'll go through the procedure in a second, you'll have a large test tube. It's a test. Hold on. I got it to be able to do better than that. Maybe, maybe not. Let's try this again. Great moments in Dr. White's. That's better. All right, you have a test tube, a big one, and you'll put some of the carboxylic acid, some of the alcohol, and some drops of the catalyst, sulfuric acid. And you have a hot plate with a beaker of water on there. You'll have a ring clamp here to a ring stand to keep it from falling over. That's one thing I teach you in the lab. And they're boiling chips because you learned about in distillation, any liquid boiling in a glass can bump, and you don't want that. Now, you're going to do a number of esters by mixing different carboxylic acids and alcohols in separate test tubes and adding sulfuric acid. And then you'll heat it for a while in water 50 degrees. How do you do that? Well, this is a 250 milliliter beaker with water. And I tell the students, heat it until you see some bubbles at the bottom, not that it's boiling, and then shut off the heat, but leave the beaker on the hot plate, and that keeps it at 50 degrees. Then afterward, what you'll do, and I'll go through this again, you'll have a beaker with some ice in the bottom, and you'll take the test tube and pour it in the beaker of ice and take the beaker out of the hood you'll be working in and go like this to smell it. And you'll write your observations. So this is a way of making different esters and smelling them. Now Dr. White's sad because you won't have the experience of smelling this, but I'll show you how you can get it. So in part A, we're going to have 2 milliliters of glacial acetic acid. The term glacial means 100% pure acetic acid, and you should be able to know, this is a common name, you should know. And 2 separate test tubes, you'll put 1 milliliter of that. In one test tube, you'll put 1 milliliter ethanol. The other test tube, you'll put 1 milliliter of this alcohol, 3-methyl 1-butanol, also common name isomeal alcohol. Then you'll mix the test tubes by tapping it, and then cautiously add drop-wise 1 milliliter sulfuric acid to each test tube. And then you'll put it into warm water for 10 minutes, and then separate each test tube. You put in a separate beaker with some ice, just a little ice there, and then you'll smell it like I showed you. You never stick your nose over a beaker or in a test tube ever to smell it. You bring the vapor, what you want to smell, the gas, to your nose, not your nose to that. And here, notice in table 1A, table 1, part 1A, the ester formed, you're supposed to draw it. And if we're in the lab right now, and I go around helping people, you'd say, oh, that smells like nail polish remover. And it is. And I won't give it away what the structure. Now, the ester you form with the isomeal alcohol, the 3-methyl 1-butanol, students have trouble with this. And why? They say, well, wait, I don't know. It smells familiar. And I'll go around and say, what's yellow and big? And it's a fruit. And all of a sudden they'll say, wow, now I can smell banana. And at first they can't. And most of them say it really smells like banana, what is it, Laffy Taffy or Taffy Laffy or whatever it's called. I'm not into that kind of candy. But anyways, what was the reason they were having trouble smelling the banana? Because the ester you make with the isoamyl alcohol and the acetic acid is the ester that gives banana its taste and smell. When you smell a banana, you're only smelling a very small amount of ester. When you make this in that beaker with the ice and go like this, you're getting a lot of ester overload. And that's where your brain and your nose have trouble at first saying that, oh, that's banana. Now, at this point, when I show that to the students and teach them that, I say, have you ever seen contains artificial flavors? I wonder where they get artificial flavors. Esters. And that's how a lot of times if you have banana or other fruits and they have artificial flavors, in a chemical plant for food grade chemicals, they have made that ester. Now in part B, you'll do similar. You'll take this carboxylic acid, salicylic acid, mix it in a test tube with 5 milliliters of this alcohol, methanol. Remember, carboxylic acid, alcohol, acid catalyst makes an ester. Then you'll mix the two together, tap it to mix it, or like this really. And then you'll add dropwise 1 milliliter concentrated sulfuric acid, heat it for 15 minutes, pour it into a beaker with a little ice, and smell it. And students see this white solid in there, and when they smell it, it's got a mint smell to it. And it really smells like mint lifesavers. And at this point, I say, if you look at the package where it says contains artificial flavors or stuff, how do you think they make that ester? Do they get it from mint leaves? No, they make this ester chemically. Now, the last ester, you'll use again glacial acetic. Glacial means 100 or pure acetic acid with this alcohol, 1-octanol, and then you'll mix it. You'll add some acid catalyst, sulfuric acid, heat it for 20 minutes. Usually I tell people do start part C first, then B, and then do A, because do the slowest one first, and you can do them all quickly. Now, here they put it in there and they say it smells of fruity. It smells almost like an orange. And guess what ester gives orange its classic smell and taste? Well, you'll know when you draw the structure. All right, let's go to the next one. Next one deals with a compound called sodium polysodium acrylate, otherwise known as superabsorbent polymer, which is found in superabsorbent diapers. Yes, and if we were face to face, I don't have any in my house, but we have them in the storeroom at ECC. I bring out a diaper, rip the part, and you see this sort of like cotton material that's not that thick, but it has a lot of this white solid in it. And that's this polysodium acrylate. How many of you have ever seen for sale or commercials for the real thin super absorbent diapers or the very absorbent feminine hygiene products? And both of those use this polymer. Now let's take a look at what is polysodium acrylate. It's this polymer right here. And the acrylate comes from this monomer used to make that eventually, I've worked with this chemical, is acrylic acid. That's the common name of that carboxylic acid. It's nasty stuff. Wait, I made a mistake. Oh, did I make a mistake? There we go. And it's that vinyl group, double bond to carbonyl with hydroxyl. And then it's made into a polymer, and then it's made into carboxylate anion. And this is really good at hydrogen bonding to water. It absorbs it. And what I have the students do, and I'll show you the chemistry in a second, this chemical is used in diapers and absorbs diapers. What's one of the key things diapers you want absorbing? Urine from a baby. And what's the main thing? Chemical in urine, babies or anybody else's? Water. And this carboxylate anion hydrogen bonds to water and holds on to it and absorbs it. In this part of the lab, you'll find out if that's true, and you'll be reacting things. Now, what you're going to do is in a beaker, weigh out 1/10 of a gram of sodium polyacrylate. It's a solid. And then you'll add, in a second beaker, add the same amount of that sodium polyacrylate. Now, you'll add 5 milliliters, DI means deionized water, and then you'll mix it and look what happened. Now, in the second beaker, and I'll show you the chemistry in a second, you'll add 10 drops of 1 molar hydrochloric acid till the pH using pH paper is 5 or lower. And then record what you see. Then you'll add to that same beaker, drop-wise, 1 molar sodium hydroxide of base until the pH is 8 or higher, and you'll record your observation. So what's going on? When you're adding HCl and water, a carboxylate anion, like the sodium carboxylate, with HCl and water, this is a base, this is an acid, you get back the carboxylic acid. So in this case, what you'll get is this carboxylic acid to all million of them. Now, the second part, you then take this and now react it with the sodium hydroxide in water. And as you learned, I'll write it down here. Take a carboxylic acid, react with a base. I showed you MOH, where M can be sodium, which it is in this case. You'll get the carboxylate anion. So by adding the sodium hydroxide, we take it right back to the sodium polyacrylate. And that's what you get. So you start with this, you make the carboxylic acid, and then you get back the carboxylate anion. And you look at, if you were in the lab, you would see the following results. In beaker 1, which is a sort of your standard, when you add the water, you get this gel material. You don't add to beaker 2, you add the water, you get the gel again. But when you add the HCl, it becomes a liquid. And when you add the sodium hydroxide, it becomes a gel again. And the question is, what's happening? Well, which one of these is a better at hydrogen bonding? This or this? I'll let you figure that out. Now, someone observed there's a lot of questions. Oh, there's not. There's only 6. Now, let me point you to number 5 and number 6. Notice what was the cause for this. In bracket, I have to answer that, use a general chemical equation for your answer. Hint, you should have already seen it already. Go back and look at the videotape for this. Now, one last thing I'd like to do. I know I couldn't find it. Huh, hold on. There, it was hiding from me. See, I knew it was right across from Detroit. I feel better now. I thought I was losing my memory. All right, let's do one thing.
Millions find a low-cost health plan at healthcare.gov. So
Time out for commercial. 5, 4, 3, 2, 1. That's the sodium polyacrylate, that powder. Don't cough on my video. Adding water. Way too much. Well, not really. Do you see how it's becoming a gel? And it's absorbing all that water. Let's see if he picks it or she picks it up. See how it absorbed that? And that's how a superabsorbent diaper works. Notice, and you'd see that in the lab with the beaker. And that's also how superabsorbent feminine hygiene products absorb that. And that's what I mean by a gel. Boy, clear your throat, guy. But anyways, is that impressive or what? I don't know what salt will do to that. But anyways, that's today's lab. So remember, this is due next Wednesday. Since we're not having class ever on Tuesday, I don't have to tell you, but if you don't know, all schools, post office and banks, I think, are closed in Illinois for election day. Don't forget the vote. Also, next Monday, I will go through the carboxylic, no, I've already done that. The amine quaternary ammonium salt amide problem set. Next Monday, I will do the review for test number 3. And by Saturday at the latest, I'll send out an email and post it as an announcement of the point breakdown, how many problems for test number 3. It'll be just like about test number 2, except instead of alcohols, ketones, aldehydes, etc., it will cover carboxylic acids, and I'll put this out in an email, but carboxylate anions, esters, amines, quaternary ammonium salts, amine salts, amides, and heterocyclic compounds. And with that, let me remind you, if you need any help, come to my office hour tonight from 6 to 7:15. If you can't come to my office hour, email me. And since we're on Zoom, you and I don't have to drive to ECC. If you need help, let me know, and I'll see if I can work something out and set up a meeting. With that, I'll say have a nice rest of the weekend. I'll see you on Monday unless you come to my office hour tonight. You can do that and come stop by and say hello. And I'll say, Gang gesund, goodbye. Remember, I stole that from Granny to Beverly Hillbillies. And Gang gesund means go in health. Bye now.